Good evening, everyone. I hope everyone's doing well. Thank you all for coming. My name is Jonathan Camboris, and I'm the administrator for the Youngstown Historical Center of Industry and Labor. It is my great honor to welcome you to tonight's continuance of the Downtown Merchants Lecture Series, an initiative that continues to bring together community leaders, nonprofit professionals, scholars, and to share their unique perspectives on the work they do, why they do it, and how it connects to our collective and industrial heritage. Over the course of this series, we've heard from a diverse array of voices, recent graduates entering the field of social history, curatorial staff, illuminating the growth of our downtown area and its industrial roots, members of the community who have lived, worked, and preserved the legacy of the industries that built Youngstown, and nonprofit leaders from memorials and libraries. Each speaker has enriched our understanding of the region's past, bringing it to life in ways that inspire, educate, and honor the sacrifices and ingenuity of those who came before us. The merchants and sponsors of this lecture series share a powerful vision to remember and honor our past while preserving what will remain for future generations. Their dedication is vital, and tonight we express our gratitude for their unwavering support, especially during these challenging economic times. Collectively with the Youngstown State University's history program, the Ohio History Connection, and the Friends of the Youngstown Historical Center of Industry and Labor, we are working to ensure that those stories of our community endure. Youngstown was and is a city built for industry by industry. When events like the explosion of the Realty Tower remind us of the physical and human labor that shaped our skyline, we are called to reflect on the hands and minds that made this city what it is. This series and our gathering tonight is a testament to our commitment to that legacy. The Mahoning Valley, with its unique geographic importance, stands as a crossroads of transportation, innovation, and industry. The connections between those processes and the labor of countless individuals resonates through time, shaping not only our past, but also our present and future. Tonight, we are privileged to hear from Mr. Carl. He is an instrumental member of our museum who worked together with our museum, along with Youngstown Steel Heritage, to recover artifacts from McDonald Steel. I can say many things about Carl outside of his kind demeanor and thoughtful approach to student engagement. What we will witness tonight will be part of a regular programming here at the Youngstown Historical Center of Industry and Labor. So as we continue this journey of learning and reflection, let us remain committed to honoring our history, preserving its artifacts, and sharing its stories. So thank you all for being a part of this important work. And thank you, Carl, for joining us this evening and presenting on the work that you do. Before this program begins, I would like to welcome back Dr. John Liana, our museum's curator. He has been well missed. So he will reflect on this series and relate it to Carl's presentation. Dr. John, welcome back.
I'm not going to talk a whole lot. The joke, better to be seen and not viewed. Okay. We will talk about the museum. I'm here, I'm back to be among my friends and my acquaintances and among the artifacts from the past and the people that made those artifacts and the stories of the people that made the artifacts. We bring to you, without politics and without agendas, just the truth. Okay? There's no room for that here. There's only room for what was. You can't change history. You can only reinterpret it. And for that reason, we are the archivists and the curators and the workers that put all this stuff together and try to make some sense out of it for our future generations. Because one day they're going to ask us, and we better have an answer. Okay, and that's part of what we're doing here. It's an answer for them. These kids come over from the university all the time, or children come with their parents, or school groups come here to learn about the steel industry that isn't here anymore. But yet we know, all of us know. If you don't, you will. Thank you very much for letting me have a couple of words. I'm not fully there yet, because most people know that I could go on for hours. Okay, but we'll just cut it short. Ladies and gentlemen, tonight, Mr. Carl Kovach.
Thank you, John. John, both Johns.
J Squared Enterprises.
There you go. How's everybody doing?
Good.
Thanks for coming. Full house. Appreciate seeing you all here. First thing I'd like to say is I hope to make this a very kind of interactive evening. We've got people in the audience that were employees of McDonald Steel. We have people in the audience that were co-workers of mine, students of mine. If anybody has anything to add to the conversation or questions, feel free to shout it out or raise your hand. All input is welcome. So, having said that, I'm going to start off by reading a little paragraph here. How many of you are even familiar with McDonald Steel and what they did? Some of you are, some of you aren't. But I have a video here, actually, that was given to me by people from McDonald Steel. I'm going to start with that. But there's a paragraph here that was from their 1996 annual report that I'd like to read first. And it says, the company produces hot rolled steel bars and specialty shaped steel products. Their products are shipped throughout the U.S. and exports to Canada, Mexico, Colombia, Taiwan, among others. They serve the following markets: transportation, construction, material handling, metal fabricating, and steel service centers, which actually they sell steel bar stock to end users, much like welding shops, machine shops, and so forth. So all the bar stock that we work with in machine shops come from companies like McDonald Steel. That having been said, let's give this video a go. And there we go. I will say this is a pretty old video and blown up on the screen. It might be a little blurry, but it's a very interesting video, very informative. And I like the music too.
McDonald Steel Corporation is the nation's leading producer of engineered hot-rolled steel special bars and shapes. Located 5 miles up the Mahoning River from Youngstown, Ohio, McDonald Steel was established in 1981 when 2 hot-rolled shape mills were acquired from U.S. Steel's former McDonald Works. Since that time, the company has earned a global reputation as a reliable, world-class supplier of the highest quality hot-rolled steel bars and shapes. McDonald Steel's hot-rolled special steel sections, profiles, or shapes, either symmetrical or asymmetrical, are used in a variety of applications: truck wheel rims, off-road equipment wheel rims, highway bridge decking and joints, high-pressure concrete water pipe couplings, car and van door hinges, and many other custom shapes, wherever low-cost alternatives to castings, forgings, and cold-formed parts are specified. Hot-rolled steel bars have been around nearly 300 years. Producing special shapes on a hot-rolled bar mill became possible about 100 years ago. Yet this process remains one of the most cost-efficient modern means of forming near-net shapes from carbon, stainless, and alloy steels. Here is a simplified graphic representation of the hot rolling process. 22 rolls, 11 sets of 2 rolls, precision machined in progressive configurations, form the semi-finished steel billet into an asymmetrical near-net shape. The billet passes through only one set of rolls at a time, allowing it to elongate on one side faster than on the other, thus accommodating an odd or unbalanced shape. This unique feature of McDonald Steel's shape mills sets it apart from other merchant bar mills, which can only roll symmetrical shapes, such as rounds, squares, angles, channels, and flats. Let's follow an actual billet as it becomes a near-net shape at McDonald Steel. Semi-finished steel billets and slabs in an exact size, length, and chemistry or grade are purchased for the specified special section to be rolled. Billets are loaded into a natural gas-fired furnace, where they are brought up to typical rolling temperature of 2,300 degrees Fahrenheit. Heat is evenly distributed throughout the body of each billet, ensuring a uniform, quality rolling temperature. The rectangular or square billet leaves the furnace at about 15 feet in length. As the steel makes its way through 11 too-high roll stands, it is progressively shaped and elongated until it exits the finishing roll stand 140 feet long and traveling at 1,100 feet per minute. This rolling and shaping journey through the mill takes less than 2 minutes from furnace to cooling bed, and the profile of the billet has changed from a rectangle to an irregular or asymmetrical near-net shape. Most of McDonald Steel's 500 different special sections were developed jointly by customers and McDonald Steel. Customer engineers and McDonald's engineers concurrently design near-net shapes, which eventually become parts of end products. This engineering process generally starts with a drawing of the desired shape sent in by a prospective customer, along with a standard set of required specifications. They jointly determine the probability of producing your shape on our rolling mills, tabulate the proprietary tooling required, calculated price per ton for the shape, a one-time price for the tooling, and schedule a possible date for a first rolling. These facts are then reviewed. When agreement is reached, our engineers, using a CAD system, start the step-by-step process of profiling the 11 sets of rolls, shear knives, roll guides, and straightening rolls, if required, that make up the tooling for producing the customer's special section. They start with the rolls in the 11th or finishing stand and work backwards to the roughing or entry stands in a sequence that looks like this. Dimensional calculations must take into consideration the temperature decline and the inherent metallurgical variations as the steel moves through the mill. For example, overall dimensions of your near net shape as it exits the finishing roll stand will be slightly larger than after it cools to room temperature. Our entire tooling design must allow for this shrinkage so that your final near net shape has the precise dimensions you specify. Most McDonald Steel special sections are proprietary, and the customer pays an initial tooling charge. Thereafter, for the life of your section, McDonald Steel provides spare rolls and will replace all worn out tooling as needed at no cost to you. And because your section is proprietary, its tooling may never be used to roll this shape for any other customer. When all of the engineering is complete, a computer-aided machining program guides the cutting of your rolls. 22 rolls are cut in step-down progression to achieve the required shape off the mill. The space or pass between each set of rolls must be absolutely exact, where the hot steel billet will be squeezed and shaped as it travels at high speed and under extreme pressure. DNC lathes produce the finishing rolls that give the hot steel its specific non-symmetrical shape and critical dimensions. These lathes are directly wired to our CAD system, guaranteeing that your finishing rolls meet exact specifications. While our roll shop is preparing your rolls, shear knives are cut and roll guides are cast, and high-quality raw material in the form of semi-finished steel billets is ordered in the specified size, length, and grade. Now the tooling is complete, and we are ready for the first rolling of your special section. We recommend that you visit our plant for this initial rolling so that you can share in the decisions which often must be made as we engineer last-minute adjustments in roll dimensions and final shape configurations. This graphic representation of a typical special section rolling should answer many of your questions about how a billet becomes a truck rim, a pipe spigot, a bridge deck, or an automotive door hinge. As you design your next component, consider McDonald Steel's special steel sections. They can save you time and money, and they add quality, strength, and precision to the end products for which they are designed and engineered. McDonald Steel is now registered and certified to the ISO 9001 International Quality Standard, as recognized in the United States by the Registrar Accreditation Board, and is operating daily within the quality criteria set by that standard. We are one of only 8 steel producers in the nation certified to the ISO 9001 standard, which signifies that we design and engineer our products as well as manufacture and distribute them. Having achieved ISO 9001, the company continues to fine-tune its quality assurance procedures to be compliant with the coveted automotive standards, some of the toughest quality standards ever set by global industry. McDonald Steel's Metallurgical Laboratory provides ongoing support for our ISO 9001 certification, plus documented reports of tests required by our customers. This fully equipped testing facility features a stress strain recorder, a tensile test machine, an abrasive cutoff saw, belt grinder, mounting press, finishing grinders, polishing wheels, a vented hood for acid etching, and a metallogram, all of which are for performing tensile and macro etch tests, as well as microstructural analyses. An even more powerful quality assurance support factor is embodied in McDonald Steel's employees. Product quality decisions rest directly in the hands of our shop floor men and women who are immediately responsible for their daily implementation. Another tangible reason for McDonald Steel's reputation for high quality is new finishing roll stands like this one, recently installed on both our 14-inch and 8-inch mills. These state-of-the-technology side-loaded roller bearing stands, equipped with hydraulic roll balancers, have demonstrated dramatic improvement in straightness, and tolerances being held many times closer than with the old stands, in longer roll life, and in excellent surface quality resulting from that extended roll life. At McDonald Steel, we are tooled to roll over 500 different special sections in common carbon grades of steel, as well as stainless and micro alloys. All 500 sections are now qualified to be rolled from electric furnace continuous cast billets and slabs. This new semi-finished steel, produced by the latest electric melt concast technology, is meeting some of our customers' highest standards and resulting in considerable savings for them. In addition to special sections, McDonald Steel produces merchant bars in uncommon sizes. Though these bars are priced slightly higher than standard commodity bars due to their unique dimensions and customer-specific lot sizes, merchant bars ordered from McDonald Steel do not require special tooling. Another McDonald Steel service is our extensive warehouse facility, complete with rail and truck containerization, just-in-time inventory stocking, and off-the-shelf shipping. As you consider ordering special sections from McDonald Steel, here are some helpful product ranges from our 14-inch cross-country shape mill and our 8-inch Belgian looping mill. When preparing your section drawing, remember that all corners and angles must be rounded. The product ranges shown here may not apply to any one shape. These are general ranges only. They may be adjusted per inquiry and should not be viewed as limitations. Please inquire per section for length limits. If you are interested in co-engineering a special section, fax, email, or mail us a drawing along with the following data: product name or application, weight per foot, length, straightness, annual tonnage required, steel grade and or chemistry, and bundle weight. In a few days, we'll tell you our capability of rolling your product, the cost of the necessary tooling, and the price per ton, plus a target first rolling date. You can count on McDonald Steel to supply prime quality hot rolled bars and shapes on time to your specs and in the exact quantity you ordered. Because we are 40% employee owned, operating under gain sharing principles, and certified to design, manufacture, and distribute via ISO 9001 quality standards. Visit our website, call, fax, or email us today about our low-cost, high-quality alternative to forgings, castings, and cold-formed sections.
Unfortunately, if any of you plan to call, those numbers are now defunct. You probably won't find anything on their website. Any questions about any of that?
Yeah, why aren't they here?
That is a good question for perhaps, I don't know if Bill or Glenn would like to. Let me go on a little bit here. Let me introduce, next thing I was going to do here. Unfortunately, it's not like a probably one sentence answer.
Oh, sure.
But yeah, as you saw in that video, they produce many, many different shapes. These are some of them here. Before I introduce Bill and Glenn, who I worked with when we were getting some artifacts out of McDonald Steel, I'd like to make the differentiation. A lot of you might think of a steel mill as making the steel. McDonald Steel didn't do that. There were other steel mills that actually create the steel, make the steel, and they would output it as either blooms, which is the large square piece on the left, or smaller billets, which are the ones in the center, or smaller bar stock on the right. And actually, this is a photo from downstairs in the museum. This is actually in the museum here downstairs. If any of you have never been here, it's worth a trip to take a walk around the museum and see. There's a lot of interesting things here about the steel industry. But the center squarish shape there, a billet, is what McDonald Steel would actually buy from another supplier. And then, as per this chart behind me, they would make the roll progressions for rolling a finished product. So, for example, at the top here of any of these photos, that would be the shape of the billet that they started with, and as it went through the progressive sets of rolls, you can see the progression to the finished part at the bottom.
Hey, Carl,
Yes.
were any of those billets produced locally that they bought from?
That's a question for Bill or Glenn. Did you hear?
Our closest supplier used to be Warren Steel Holdings, which is the old CSC facility in Champion area. That was the only really local material supplier we could use because they did a rectangular cross section, or they had the ability to do rectangular cross section. Mills like Valor that do tubing would cast around, and then you could pierce it or something, and just basically the tube shape was already there. It's just you have to make the wall fit. So we couldn't do that because if you put a round in our furnace, it would roll right down the end. There was no way to actually have it walk through the furnace and cut the temperature. We just go in the back and roll right down. But the Warren Steel Holdings / CSC actually did a rectangular and round smoke, so we were able to buy out them. Other than that, our closest suppliers would be Nucor in New York, SDI in Roanoke, Virginia, SDI Steel West Virginia facility, Huntington, West Virginia, Arkansas Steel. They have a variable width caster that you can get any width you want as long as it was a minimum of 4.5 inches thick. So you go 17 by 4, 17 by 4.5. Their caster actually had a variable width. And then we had a supplier in Canada that actually did SBQ quality, SBQ special bar quality. Very clean, very highly processed material. So some of our more critical products would come from that facility, as long as it didn't have a make an American specification. If it did, then we'd have to go to like an SDI Pittsburgh. They had the same type of equipment, but their lot sizes were much larger.
What was the major grades they produced?
Major grades of
Steel.
well,
End-use products.
If you're in the video, there was a variety of business industries that we serve. And what Glenn was doing, we look at each of the industry sections and find out, is this a cross section we could produce? And then based on the section, that information regarding the grade of the material would come to me or one of our other associates in the sales department. And we would kind of scour the country. Typically, construction grades would be 836 or 8588. 836 is structural grade. 8580 is the structural grade. And if you ever the weathering steel, they used to use it in bridges a lot because then you had to paint it after it rained on it a few times. You got salt on it a couple times, turns nice brown color. Then it would corrode any deeper than a few thousandths of an inch. So those were the structural grades. Those have been replaced by higher tensile yield grades like 8709, grade 50, 8572. And there's still structural grades for like normal ankles and channels and stuff you would buy at Home Depot or Lowe's. That would be structural 836. And some of the bridge construction 6 shapes would still be 36 or 8588.
Wheel stock, just basic.
Wheel stock was actually like a 1010.
1010.
About a 1010 because it had that circular forming going on. And you had to be careful because how they circled it could also crack the material along the circumference or across the circumference. So it was a very, very kind of a violent process. And they did all that forming cold. There was no heat on the material when they were formed because they wanted the properties of steel to be very stiff to hold the truck rim. Because when I went to visit one of my customers that made those rims, one I went on a tour, and he tried to explain to us that you have to understand that the people that work on our shop floor are actually certified for pressure vessel welding. And it's like, you guys do your own like pressure repairs? He goes, no, not exactly. Because if you think about a rim, you put that 12-foot diameter tire that you see on the side of the interstate around that rim, you pump it up to 125 psi, that's a pressure vessel. So So,
The overwhelming grade of carbon grade, very, very egregious carbon, went from 1010, somewhere up to 10.
Did you ever get anything from US Steel Ohio Works?
Well, that's when the Ohio Works was open, and the McDonald Works was open. A lot of the bills came from the Ohio Works.
I remember shipping up, I was in conditioning, the last department before everything got shipped out.
Yeah.
So I remember McDonald, we would have cars going to.
Right. So that was before my time.
Yeah.
When I know.
74.
They actually relied on the work hardening of the making the rim to become, provide the stiffness of the rim, of the wheel rim.
Well, I'm not, metallurgy is on my area of specialty, but I'm not so
You're the
sure.
metallurgist.
That's the work hardening enters the picture. Once the grade is
What point did you
specified,
lose control?
do. Good enough to do.
Was that a big end use product that you guys made, Will?
Well, back in the 40s and 50s, in the heyday of the McDonald holding room, rim base for truck applications, that facility was full of tons and tons and tons of
High carbon steel?
What's the
high carbon.
Was the car rim too also, or just?
No car rent, well, they used to go way back in time, and some components were used on cars.
Who was your biggest competitor?
Our biggest competitor would probably come from facility builders.
There you go.
Yes,
Our biggest,
foreign as usual.
our biggest competitor towards the last 20 years, there was a big company in Turkey called Janssen. And
That's a
they
good question.
used us because they wanted to look at us for raw material, but back in the shipping charge and everything else, they still were buying the shipping materials from like British Steel. They had a shipping mill in Britain, they could, the trucker basically would get to a port that's very short distance as opposed to 13 weeks on a vessel getting it from here. But Jansa, there was a few other, Komatsu had a room plant, people of that sort, so. Once again, it just depends on the industry. A lot of stuff,
The rim industry sort of went by the wayside as time went on. Those multiple piece truck wheels were replaced by like strip. The strip was just one through set of dies circled and the wheels made that way. And so those multiple piece component wheels, they started going by the wayside probably in the early 90s. So
You guys see this thing going back? This kind of thing? Neighborhood mills.
I don't.
Don't think it's cyclical, some drive down the road, is we're gonna have to. Somebody's gotta do it.
At this point, and this is my opinion, I'm going to say no, but
That's-
Okay, do we have it?
Just one more quick thing, just to give you an example from what you've seen, there, we would go on the big mill, our 14-inch mill, I think you've seen that sheet that Carl had up there, the biggest weight per foot was 35 pounds per foot. So for us to get down to 35 pounds per foot, we would have to have something significantly larger than 35 pounds per foot going into the furnace. The second mill that we used to run, which we mothballed probably a decade and a half ago because we couldn't compete with China, we would actually start with a 2x2 or smaller, an inch and 3/4, 2 inch, 2 1/4, 2 1/2. And a hand roll, now that looping mill that you see the guy with Thompson with looped around and all that, if anybody in this room, probably, Glenn and I are probably a few years old enough, if you ever heard his name, Clint Eastwood, he played a character called Dirty Harry. We actually rolled stainless steel, 410 stainless, on that small mill in the shape that Sterling Ruger would then make the Dirty Harry come out. So once again, there's a lot of variety in terms of who needed what, when, and where, out of what. And that's where between the grade and what he was able to do on the mill, and the guys that Bill were able to do with what he gave them, it created sort of like a cotton kind of industry.
Yes, McDonald Steel filled a very unique niche, actually, in the products that they produced. Okay, getting on to how I got involved with this. Glenn, correct me if I'm wrong, it's about March last year when it was announced that McDonald Steel would be closing. And one of Glenn's superiors came to him and said, why don't you get a hold of the Steel Museum downtown, which is here. And he got a hold of John and set up a tour for us to go through McDonald Steel. John graciously called me, and when I found out about it, when it would be, it was the day that I was teaching class. So my next question to John was, can I bring students? Because I had class that day, and I thought it'd be a great opportunity for a field trip. So that's what we did. And that was April 9th last year. So shortly after we took that trip, that's when I first met Glenn. I don't think I'd met Bill then yet. And John came up with what we were calling a wish list of things that we would like to get from McDonald Steel. Because actually it was just mind-boggling after we took that tour, and I have some pictures to follow here. The amount of information there is just incredible, mind-boggling. In a relatively small area of Glenn's office and the tool room off of that, it's just an entire history of the company, even going back to when it started as a U.S. steel plant back in 1917, I believe. So, and it was interesting too, because of the handful of people that took the tour that day, we all kind of had a different take on different things that we thought should be salvaged. We all agreed that it all needed to be salvaged, but obviously that was not really possible. So this was just an initial list that John, myself, and Susan, who works at the museum here, had come up with. And I was gracious that I got to say so in things that I might find useful. And the next series of slides will just give you an idea of Glenn's office and just the amount of history that is there. These are drawing cabinets. Each one of those drawers in the gray cabinet on the right holds 24 by 36 inch drawings. Each drawer probably holds 100 at least, close to it. There were multiple file cabinets. Well, both of those file cabinets actually. Regular file cabinets with all sorts of card catalogs, log books. That was one of Glenn's drawing tables, which actually the museum has that. It's in the basement here right now. That's an optical comparator that Glenn used on a daily basis. That's actually sitting right there at the front of the room here. I'll talk about that in a little bit. And this is a room, this was new to me. I'd never seen this. As long as I've been machining, we always worked off of blueprints. And this was something new to me. These are wooden boards. A lot of them I have laying up here on the tables. The profiles of the rolls, they would actually draw them on 3/4 inch thick wooden boards. Because once those patterns were drawn, the drawings, when they'd go out to the shop, paper would get torn, oily, dirty, whatever. So they actually drew the patterns on wooden boards just for longevity, really. And they had an entire room hanging like that, just like clothes on a hanger, basically. Those are the profiles of a lot of the rolls that they created. And I tried to take some pictures so you could actually see them. It's hard to see on the video, but again, I have these same ones that I took the picture of laying up here on the table, if any of you care to look at that afterwards. And then this was a room, all those cabinets on the right were steel gauges that were created off of those wooden boards. Again, I have some of the gauges up here on the table. And those gauges were used to make the form tools that I'm going to talk about a little bit, and also the tracing templates, and which ultimately made the shapes of the rolls. This picture, this was a lot of the form tools, and there were rows of these. It was just, again, just mind-boggling, the amount of tooling and the categorization of everything. And then on the right, you can see some of the tools marked with 7, 6, 8, 9. Those were the tools for the specific shapes of the rolls that went in that number roll stand. And again, I have a lot of that up here on the table, and I'll get more into that here in a little bit. Also, for each of the different shapes, as I mentioned in the video, there were guides that guided the hot steel into the rolls, which some are at the bottom right there. And in this set of drawers, I believe, were the patterns, or
Those were the template
the
drawers.
template drawers thing.
And what you see standing up on edge are the wooden guide patterns that the cast iron mill guides were made from.
Right, yeah, in McDonald Steel, they had their own wooden pattern shop, so any castings that needed made, they would actually create the wooden patterns, which these are. And then they make the cast part, which actually I have one of the cast pieces up here on the table also. And then there was the vault. This was a very tiny room, but the amount of information in this room, again, was just overwhelming. Each of these little cubby holes held the samples of the rolled steel for any one given shape. And as it went through the 11 different sets of rolls, they cut a short section of it and marked a number on it and put it in the bin here. So at any point, you could go and reference back to that and actually see the progressions of that particular shape. And in the vault above, you can start to see some of the old books and log books, and just an incredible amount of history of the company. And this is back out in Glenn's office. This was a display case on the wall, one of several. This gives you an idea of all the different shapes that they rolled. And this display case and all of the contents, we ended up bringing here. It's also in the basement also. Right now it's distributed among probably about at least a dozen pallets in boxes. We have a room across the hallway here that the museum will be setting up for a McDonald Steel exhibit. It's going to take some time, but all of this eventually will be back on display here in the museum. But if you look at that, that's a pretty incredible amount of different shapes. In any one of those sections. This was another display case. This was from their smaller mill. The previous display case was from their 14-inch mill. This was from the 8 and 10-inch mills, made slightly smaller products, but again, with a variety of different shapes that they rolled. And imagine that there were a whole bunch of rolls that needed turned on the lathe to create these parts. This is yet a different display case. And there's some of the, at the bottom is what the profile of the steel bar when it came through the final finishing pass. And on top are what the finished part after there was some, it was cut to length, and then some secondary machining operations, and that would be a finished part. Glenn, I'm sure you know what parts those were. It looks like some sort of a hinge.
And that was a component that held a car door on. There was a bigger component that attached to the chassis of the car, frame,
Mm-hmm.
and then the smaller one attached to the door. And you see the holes in the rounded part with the noses sticking out. There was a pivot one in there, and it's made with the piece that was on the body of the car, and that was the swing of the door.
Have any of you ever had a chance to go through or work that Lordstown when they were in business, for the years they were here? Originally, a lot of the stuff was assembled intact. As they did more automation and tried to do some rust proofing and galvanizing or whatever, it improved the durability of cars' bodies. They did the doors on, doors off program. And the piece of what they talked about, the smaller ones on the screen, is the door profile. And Glenn mentioned the bigger one would be on the body, and they would go in different directions. They wouldn't be anywhere near the same area of the facility, because a lot of times at Lordstown, they actually had the doors assembled off-site. The only difference was that somehow when you got doors coming in from the top of the ceiling and cars coming up from the basement getting dipped, the two doors better match the color of the car, because they're getting painted separately and everything else. And the doors on, doors off required, once again, that hinge pin and hole had to line up perfectly with what was coming up from the basement. And if it didn't, lights went off and sirens and all kind of stuff. So, that just gives you an indication. The small little piece that went into from our facility, in that case, those are designed for Volkswagen. Volkswagen and use those hinges. And we also did the Jeep Wrangler at one point, and several GMC trucks.
And we have an ex-GM employee here, and he's probably familiar with some of this. Any comment?
Let's not bring up that anymore.
This is another one of the profiles. Again, that profile of that shape is what the rolled finished product was. But then it was, again, further machined, holes added to it to create a part that looked like that. I have no idea what this part is.
That's the main component. That's what we can attach to the chassis of the car.
Oh, those two parts go together? Oh, no kidding, okay. I had no idea. I found those in that box that you gave me of parts out of the metallurgical department.
Draw a little bit of metallurgy. I don't know if you've ever had a chance to look at an automotive hinge on your car, probably not. But our original founding father used to go into the car dealerships and he'd take a 2x4 and corner the car door. He doesn't flex at all, but these hinges on there, the stamp hinges, you can bend them around and all kinds of stuff. But anyway, that hole in there, if you had steel to steel and you were opening and closing the door hinge pin, then you would have that friction and contact surfaces, they would always rust out. So a lot of the upgrades were to put a bushing in there, a fiber bushing, to prevent galvanic corrosion. And that solved the rust problem. But because of the metallurgy involved with the salt and the water salt sprays and everything else, you get a thin cherry during the winter, and getting caught between the hinge pin and whatever else, you get the galvanic corrosion because it's actually created almost like a flux with that bushing in there, there was a fiber composition bushing, it basically sealed it. These are different things. When you see in high school chemistry, you don't think it really means anything. You find out after, 30 years after the fact, oh, that's why. Okay.
If Bill sounds like he was into metallurgy and that type of thing, it's because that was his job at McDonald Steel. His quality control, and I'll get into that here in a minute. Actually, Sue took this picture. A lot of citations here. A lot of these photos, some I took, some Sue took, some Martha took. This is a photo that Sue took. This little section of this building right here, of the whole sprawling part of McDonald Steel, was where Glenn's office was, where all of these photos were taken. And like I said a little bit ago, the entire history of the company was basically packed in an area probably not any bigger than this room when it comes down to square footage. Okay, so coming here, to move along here. So we had gone over, took the tour, we made a wish list. And one of the things I had asked Glenn for, and this was in conjunction with the fact that I was teaching machining, I'd asked him to select one shape that they rolled, and I wanted everything associated with that shape. Any drawings, any change drawings, any tooling, the form tools, the tracing templates, the gauges, the guides. And this was the shape that we settled on. And actually, I have to apologize to Glenn. I initially told him that he had one picked out with everything. And when I went to pick up all the tooling and everything and saw the amount of form tooling that went with it, it's like, I didn't have a way to transport it. There was that much. So this was the shape that I had acquired, all of the tooling and everything that's up here on the tables. This was M4661. And this was the original drawing. Again, it's laying up here on the table if anyone wants to look at it. If you were to look at the date, this was from 1957 for Firestone Products. This is obviously before McDonald Steel owned the place. So this is interesting from the fact that this particular shape and profile was rolled in that mill when US Steel still owned it. And over the years, Glenn gave me the entire folder of all of the drawings and everything pertaining to this shape. And looking through that folder, I found the same shape with, I think, 4 different company names. It changed from Firestone, it was Goodyear at one point, Can-Am, I can't think of the other one. Titan Wheel. And this gives you an idea of what this part does. Again, this is if you took a truck tire and cut it in half and looked at the edge of it, this is the profile that you would see. And that part is right there. It was a 3-piece rim. There's a wider part here. And then that part and this little locking ring that held it all together.
That small lock was rolling the 8-inch.
Say it again, sorry, Bill.
The small lock room that you have there in the upper right-hand corner, that actually was more on the 8-inch mill as well.
Oh, okay.
We did the shape that you're talking about, which is the side flange on the top, and then the lock ring underneath it. So, and the rim base was done on 14-inch mill, so we actually did all 3 components of it.
Great. Yeah, I wasn't aware of that. Thank you.
Were they all welded together then?
No, all 3
It's
different pieces, 3 different frames.
Yeah, the black spot right there, there actually is an O-ring there, right? It's a seal to to keep the air in between the two steel pieces. So from that 4661 shape, again, these are some of the original drawings that came from Glenn. This shows the progression of the different rolls. Down here, this started, you can see the book, I don't know if you can actually see it. It says down there, this started as a 4.5 inch square billet. And as it went through the first roll, it was reduced to 3 inches in diameter. The second set of rolls, it took on that shape. The next set of rolls, it took on that shape. Up to here, number 6, which I have all the tooling and everything for on the tables up here. And then to number 7 set of rolls, 8, 9, 10, and the finishing rolls. So it's quite a drastic difference from this to that, isn't it? But again, that was all done just running through sets of round rollers that were machined to these contours. And then there were gauges also made for checking the dimensions. This is a profile of the finished part. This gauge was made, and I actually have one of these on the table up here. For checking, as you see there, 1.157, that was the dimension from this flat edge over to the end of the part right there. And this is what's commonly known as a go-no-go gauge. Very quick, easy way to check if the part was in tolerance without having to pick up calipers or micrometers or measuring devices. And Bill, I don't know if you're aware of this, your name's on this one. This is the actual drawing in that I found per Catco for inspection. That's Bill. So backing up. So the reason I requested all of this, I felt it was important. John had asked me when he asked me to do this presentation, why I thought that it was important of the things that I requested from the museum. And from a machining standpoint, everything that was created in that roll, in the mill rather, was created on. All of those rolls that form those products were created on the lathe. And the lathe is one of the most basic machines out there, along with the milling machine. But through the history of the company, they used several different types of lathes and lathe technology. And for that reason, that's why I asked Glenn to pick one profile and allow me to have everything that went along with creating that profile. I wanted to set up a table in my machining lab to educate my students, and we used to have a lot of other traffic through the shop also, just to educate everybody in general, in conjunction with the Steel Museum here. So that being said, we'll get into the nitty gritty of it here. Is there anybody here that has no idea what a lathe is? And don't be ashamed to put your hand up. Rick, I saw that. Well, I'm prepared for you, because this is a basic lathe. But I think I can skip over a lot of this. Again, just to touch on it, again, basic lathe. This is a work holding device. You're working with a round cylinder. It's held in a work holding device called the chuck. There's a tool mounted here. And as the piece rotates, you can move a tool left to right or in and out, and that tool will cut that piece of metal. So you're basically always working with a cylindrical shape. This is a photo of a small engine lathe from McDonald Steel, courtesy of Rick. He took this picture. And again, just basics here. These are some of the operations. I'm only going to talk about basically these two. But again, as I mentioned, your tool can move in and out or left and right. And by doing that, you can either cut the end of your part, which is called facing, or you could do tapers. You can cut corners, which is a chamfer. You can cut it off completely. You can do threading. You can do boring, drilling on the inside of a part, drilling on the outside. Again, the main two right here is forming and contouring. And the oldest lathes that McDonald Steel had utilized the forming. And for any of you that, I'm sure there's a lot of you that don't have any idea what that is. I actually shot this video in my shop. I took a piece of plastic, the tool you see at the bottom here, is right here. This was one that I got from McDonald Steel. This was actually in the scrap bin when we ended up going through there. This is the same tool that you see at the bottom there. Oh, I gotta go over here to start this. Basically, the tool moves straight into the part, and the form of that tool ends up on the round cylinder. And that's the basis of everything that they did at McDonald Steel. So yeah, here's the tool, here's the part. Kind of matches perfectly, doesn't it?
What kind of steel was the shapes made out of? On each side, on the cutting tool and the final roll? What kind of steel was that to be able to take the heat and everything of forming that?
That was made of some specific form of grade of tool steel.
Okay.
I don't know the specifics. I don't know if Glenn or Bill. And he was asking about what types of, what grade of steel that the tools might have been made from, and then also the rolls.
Yeah, mostly the rolls. What kind of steel was that?
The rolls are one of two grades. They were either cast iron alloy or cast steel alloy. The cutting tools were high-speed steel or some type of carbide steel.
Because typically, how long would those rolls last before you had to recut them? So that's a lot of pressure and a lot of heat.
Well, they were probably good for one rolling campaign, which consisted of anywhere from 100 to 600 tons. Typically, there were multiple passes in a roll. So some of the rolling campaigns would utilize only one of the two. So it would go back and storage with one clean pass and one used pass. And the next time the rolling campaign came up, they would build up on a clean pass. And after that one was used, they would come back to the shop for redress.
Thank you.
So that's basically what a form tool is. And if you noticed in that video, all those chips coming off of there, imagine if that form tool is going into a piece of steel. That's a lot of steel you're removing off of a roll. And a lot of very high forces generated. So these roll lathes, which I have some pictures coming up here, were just massively powerful machines. Oops. These are some photos of some form tools. Again, this is for that 4661 shape that I have the tooling for. These were for, I believe, number 9 stand. Yeah, the ones on the left were from the bottom set of rolls. These two form the contours on the top set of rolls.
Carl, you have a picture of those tools on the actual lathe. What holds those? It sure isn't a person holding it like a wood lathe.
You're right. We'll get, yeah, I have some pictures of the lathes coming up. Yeah, good question. This is the number 6. For number 6 stand, this was one basic tool created that whole profile. And this was there's several different small angles up here. It's hard to see. So this tool roughed the entire shape, and this one they went in just to basically create the accuracy on those angles and lengths of the angles. These were some of the steel gauges that were made from those wooden patterns. This was from the number 2 pass. So that basic entire contour shape was what the piece of steel looked like after it went through the number 2 set of stands. There's the number 6 that I mentioned. This is for the number 10 set of rolls. These were all the different steel gauges that were made for checking the tools, for checking the finished product. This was a gauge made for a lot of times after they rolled a whole length of product, it needed straightened. As it cooled off, it would twist and warp a little bit. So there was a set of straightening rolls that it went through. And this was the gauge for making the straightening rolls. The contour on the bottom was the contour that was machined into the bottom roll, and the contour along the top was machined into the top set of rolls. Again, these were all just other various gauges associated with M4661 profile. Again, you know, no-go gauges for checking. This one checked 1.7 dimension, which, if I remember right, was from the edge here to here. But yeah, by looking at the original blueprint and finding the dimensions, you can determine exactly what these gauges were for. This was the gauge that I showed a picture of, or the drawing of earlier. Again, that's on the table up here. And this gives you an idea. I might be jumping ahead here a little bit. This thing at the top is one of the templates that was used on the tracing lathes. But I took this photo again. These are the form tools on the bottom, the way it had been done until the advent of the tracing lathe. When the tracing template was done, you can see the contour there that was created by both methods. Okay, here we get into this is one of the roll lathes with a set of rolls on it. Here we have the bottom roll and the top roll. And if you look between them, that's where the hot piece of steel went and was created by those rolls. Oops, let me back up. And actually, this is standing on the other side of that lathe. When we first took that first tour, Sue had taken this picture. It was basically, there's Glenn, John, myself, and 2 of my students, one of which is here. Pete, you recognize yourself? Another view of the lathe. Dale, to answer your question, this flat surface right here, all these square holes, is where those form tools were mounted. And they would use little wedges down in those holes to be able to shift the tool left or right. And then there were screws here and back here. I think there's a couple other views. Let me go back. But yeah, that was one of the things I'll point out here, just the differences between the form lathes and using the form tools, and then when it moved to the tracing lathes, and then eventually the CNC lathes. But this whole area right here is where the tools were mounted, and to the machinists that are in this room, you're probably wondering, where's the handle for the cross slide? There isn't one. Again, the tools were, there's a jack screw here, one here and here. The tools were mounted on there. In this bin here were little square wedges that went in those holes. They literally would wedge the tools in there and with a hammer, jack them back and forth a little bit so you get your dimensions. Adjust the screws to feed the tool in a little bit more. There were a couple of lathe hands from McDonald Steel that I was hoping that would be here tonight. I don't think any of them made it here. If they are, please shout out. I haven't met them yet. But yeah, I would have loved to like shadow one of these guys for probably a week, just watching how they did it. This is like probably a dead art, unfortunately.
Once the rolls were cut, were they ever heat treated?
Say it again, I didn't hear you.
Were the rolls heat treated after they were cut?
No,
Probably not.
never used that.
And that's an aerial view of the same lathe. There was a catwalk, an upper walkway around the whole machine shop. I took that picture of the same lathe from up there. And actually, one of the other people that acquired things from McDonald Steel was Rick. Some of you may have been here on his presentations. He owns the Youngstown Steel Heritage Museum, which is a couple miles away from here. Rick acquired, this is one of the actual roll lathes out of McDonald Steel, set up in his facility with an older set of rolls that he acquired.
You're gonna come out in the spring and help us set it up. So we can run it too.
Oh, absolutely. I'm there.
That's gonna be your lathe right there.
I'm digging it. But yeah, again, this, along the front here is where the tools mount. This is interesting too. This is kind of a left-handed lathe. Usually the motor drive is on the left side of the lathe. This one's on the right. When I first glanced at this picture, I thought it was the back of the machine. It actually isn't. And another interesting note on that for the machinists in the room, there was actually a lathe at McDonald Steel that had a headstock on both ends. It was huge. It was probably, maybe not from here to that wall long, but pretty darn close. So actually 2 people could be running the same machine on opposite ends of the machine. Okay, so getting into, that was basically the roll lathes and the form tools that we had covered so far. And then technology moved to a tracing lathe. And there were tracing templates. These 2 on the top are templates. These are made out of masonite. These are up here on the table also with the original board drawing. These are some of the metal tracing templates for the same shape once they went to the tracing lathes. This is for number 6 stand. The one on the top here was the contour that was machined into the top roll. The bottom one was machined into the bottom roll. If you take one of the templates and flip it over and put them together, that shape is what was between the rolls, where the metal passed, created that shape. So that was number 6 set of rolls. There was number 7 set of rolls. Number 8. Number 9, 10, and 11, the finishing set. So that was the shape that the finished product looked like after it had passed through all of those different sets of rolls. Anybody have any questions or anything about that? No, good. And this is one of the tracer lathes. This is a view from the headstock end. The headstock is here where the motor and the drive mechanism is. This is from the opposite end. And there's some other, this area along the top here is where the templates were mounted. And this was the apron of the machine. This hand wheel here would move your tool in and out across the part. The other wheel on the left would move the whole carriage left or right. These various levers were for engaging automatic feeds. This is from the back of the machine. And all these tubing, all this piping and tubing, these were hydraulically operated. And there's an aerial view from up on the catwalk again. But basically, this is the tool block where the tool was mounted, and there's a tool mounted. It's hard to see, but right here was the actual cutting tool. And on the tracing lathe, as opposed to the form tool lathes, again, you had to grind the shape of the form into the tool to create that same shape on the roll. A tracing lathe used a single point tool like this. It was usually a pretty small tool that had a radius on it. And that radius matched the stylus. The stylus would follow that template and move in and out and create that contour. And that is the actual cutting tool right there. This photo shows the relationship. This vertical piece right here is actually the stylus. The template was mounted up above here, and your tool was over here. And your workpiece was mounted off of the headstock here. It was rotating between the stylus and the tool. So as the stylus up here moved in and out along the contour of the template, the tool over here followed that and actually cut it into the roll. There's another view of the stylus right here. And you can see a better area up here under these rectangular pieces the way they clamp the template down. And I was pretty excited when I saw this, when I took the tour, because when I went to school for machining an eon ago, we had a tracing lathe in school, and we all had to do a project on it. And actually, I still have that. At the time, I don't know why, lamp bases were a big thing, and most people in wood shops were into making bowling pin lamps. Don't ask me why. They try to talk a bowling alley out of an old beat up bowling pin, and they drill a hole through the end and put a lampshade on it and call it a lamp. Well, I wasn't into bowling pins, so I basically did this on a tracer lathe in school, in high school. There's two different, I made a template for that shape, I made a template for that shape, and used a tracing lathe, not quite as big as this one, but again, the same technology. So yeah, when I saw the tracing lathes there, I was pretty excited. As a matter of fact, Pete was one of my students with me. I had just been talking to my students, I don't think it was a week before that, about tracing lathes. Because that's another reason why I thought this was important to obtain some of this tooling and this history. A lot of my students, well, most of my students are in their early 20s, some of them right out of high school. Some of them can't even wrap their heads around the fact that a phone used to be attached to a wall with a cord. And most of them think that, well, without a CNC machine, you can't machine anything. Well, no. So yeah, I thought this was, again, that's, my eyes kind of lit up when I saw these older lathes to help teach my students that long before there were computer-controlled machines, we were still machining a lot of intricate detail and shapes. Rick, did you have a question?
No.
Um,
Keep going.
Actually, this is on the back of the machine. Along here, actually different, some of the styluses. Again, the stylus generally matched the radius on the tool, so it would create a one-to-one, although you could change the size between them if you needed to enlarge or reduce the pattern slightly. And then this was the CNC machine. I forget how, did you have 2 CNCs? 3. So yeah, McDonald Steel had how many roll lathes? I'm not sure. I know there were 3 tracer lathes and then 2
tracers, 2
2
CNCs,
CNCs.
and a bunch of old block lathes.
Okay. The machinists in the room and some of my students would probably marvel at the complexity of the control panel there. Now, actually, McDonald Steel acquired these, I think, in the mid-90s. So this is, we're looking at mid-90s technology. And as opposed to the block lathes that had no dials on the front, or no hand wheels, to the tracing lathes that did. Again, this is the front of the CNC machine. All you had down here was some push buttons, basically a hand wheel here. You can move it in or out. Again, you control it basically with a couple of push buttons. The 3 buttons here were your different feed rates. Pretty simplistic, but there's a close-up of the control panel. And this was a shot that I took from up above. This was the entire machine shop at McDonald Steel. The roll shop and those lathes that I just showed you were confined down to this one end of the shop, just to give you an idea of the size of the area. Those machines were pretty large in themselves, but those are all down in this general area. Any questions so far?
Carl, just want to comment, when you were talking about the form tools and the old block lathes and the roll turning done by hand. Once the roll turners had the tools chucked up and started the process, it was a very slow process. Those rolls turned at a very slow RPM in those lathes. But the turning process required constant attention from the roll turner. But the process itself, there's a lot of analogies between that and watching paint dry. Yeah, it's a very slow process by hand.
Why did we get 24?
I can believe
There's so many of them.
Right.
So what circumstances would use the old block lathes as opposed to
And the old block lathes were used, were still used present day to pick up intricate parts of the past, where the tooling for the tracer lathe, the CNC couldn't get to. So they would turn the majority of the roll in one of the 2 ways, tracer, CNC. And then if it had the intricacies of the past, that tooling couldn't get to put it in the block, but it came out by hand.
And actually, to further that point, one of the bonuses, I happened to be at McDonald Steel one day, and one of the old lathe hands came in, and Glenn introduced me to him. His name was Craig. I was hoping he'd be here tonight. I'm not sure what happened. And I asked him, because, again, any of the machinists in the room would know if you take a tool that wide, plunge it straight into a piece of steel, what's gonna happen? It's gonna chatter like this, son of a gun, isn't it? And that was the question I asked Craig, and he said, those lathes, those old roll lathes, they would run those down as low as 2 RPM. And which goes hand in hand with what Glenn was saying, it's probably akin to watching paint dry. Took a long time, but again, that one tool, you have to consider, is removing a hell of a lot of material. And yes, it was a slow process.
There any kind of cooling system?
I'm sure there was
Water,
cooling, I'm sure there was,
oil.
yeah, typically any
Okay.
lathe or machine tool is gonna have some sort of coolant on it, cutting oil.
I didn't see anything like where it looked like it would be spraying through water.
I'm sure there was.
For the block blades, no cooling there.
Really?
And there was no cooling that I remember on either the tracer or the CNCs.
Wow.
No, there was no cooling on
That's very surprising, yeah.
it. And to further that point, every once in a while, a guy would put a rag on there to sort of shield the metal fragments.
The chips coming off.
And the rag would catch on fire.
There you go. Yeah, because again, removing that much metal, again, the machinists in the room would know, they come off, the chips come off, they're pretty darn hot. I've had, well, all of us have had multiple burns on our arms, necks, wherever those chips land. Yeah, they're hot.
What was the theory behind no cooling?
I'm not sure.
I have an answer for that.
Me neither. I'm surprised to hear that they didn't have coolant.
CNC, I
Yeah.
never seen without cooling on it. We got stainless steel.
The only process to use cooling was on a milling machine. So the cooling run on that, so as far as blades, it worked.
There you got flavor.
And then also with all of these products that were rolled of different shapes, there was a lot of metallurgy involved, which was Bill's neck of the woods here. This was one of the tensile testers that they had there. That's one component of it, that's the other part of it. Again, they had to do all sorts of different testing on the chemistry of the materials. The hardness, the tensile strength, the yield strength, the elongation strength. So that was a whole nother ballgame that the metallurgy department took care of. This is just some of the equipment from that area. This is a metallograph, the same thing is on the table up here. It's actually plugged in if anybody wants to come up and look through it later. This was used at high magnification to look at, you could actually see the actual grain structure of the steel. And they could do analysis that way. The sample goes right on top here. This is a light source off to the right that shines in and hits various mirrors. This particular metallograph could be used for high quality photography of the grain structure of the metal. This is one of the typical photo. Again, you're looking at the surface of a piece of steel here, you can actually see the grains and the grain structure of the steel, and any carbon or any other inclusions or other makeup of the metal. And this is also up here on the table too, this same picture. This is just a close-up of the different lenses here. You could revolve it 5 different lenses, 5 different magnifications. This particular machine is an older one. This is set up, you could use any sort of camera to capture the high magnification images. 35 millimeter going back to all the way to the old Polaroid land cameras. There were attachments that fit onto the front and side of it for high resolution photography. And that's the control. Again, you can set it for different ASA film speeds, whether you're using color, black and white, getting into that kind of things. And this was also one of the rough rolls that was laying in the plant when we took the tour. This is what the rolls look like before they were machined. And in conjunction with that 4661 shape, something I was hoping to do, the Mastercam gods didn't agree with me. I was hoping to machine a set of rolls in miniature version that everybody could see. I actually got one of them machined for that shape that I selected that Glenn had given me all the tooling for. This is the number 10 roll. Glenn's last day was back in the fall, and he and I had a conversation. When I had this idea, it was just a month or so ago, and I talked to him about it. He said, let me check my files, and he actually still had on a USB drive somewhere where he had taken one of the original shapes off of the tracing templates up here, converted it to CAD for the CNC machine, and he emailed it to me, and I was able to take that shape and scale it down, and this is an exact replica of the top roll for the number 10 roll stand. This was going to be, and it still is, just not done yet, the bottom roll. And I do intend to finish this and put it in a little makeshift roll stand here to leave at the museum here with this particular rolled shape. So, yeah, I can pass this around. Again, it's, a lot of people can't visualize going from this to that, but yeah, this shape, if you were to look in these two valleys, that created the top half of the contour, and the other one created the bottom half. So there you go. Does anybody have any other questions or anything they want to add, or if not, that's pretty much the end of my presentation. Again, a lot of the things that I took pictures of in the slideshow are up here on the table. Feel free to come up and take a look. I forgot to talk about the comparator over there. On that, if you see a shape on the screen, that basically magnifies, that's a 5 times lens in there. There's also a 10 and 20 time lens. That allowed, we actually had a smaller version of this in my machining lab. And you could use that for checking small detail, minute detail on a part. You could actually see the shadow of the part and take measurements. You could take very accurate measurements off of that. And that was used extensively. That came directly out of Glenn's office for checking and creating a lot of the gauges and tools and so forth that were used.
So what are your plans with all this? I know you said you're going to open up a room here for McDonald Steel, but how is that going to be promoted? Are you guys going after young machinists, having them come in just like they would here anyhow, or do you have special plans for this McDonald Steel exhibit?
Well, the basic plan for the McDonald Steel exhibit is to be here at the museum, and everything that I showed you, all those drawers and boards and everything, is just to kind of recreate, to not let that die. The trajectory of the museum here isn't so much about, getting machinists involved. I mean, if they come and see it, great. But I had acquired all of this when I was machining, and running the machining lab to show my students, to just show them how things used to be done and so forth. I don't know if that completely answered your question.
I could add to that, Carl.
Sure.
So
please.
first off, thank you so much.
Thank you.
So there's sort of multiple phases in where we're at presently. The first phase has been, and it's continuous, to preserve what we have acquired. And that is still ongoing. We have to sort of identify every single item, but we can place them in groups. So we have patterns, we have blueprints, we have, the different types of things out of each category, right? The next would be then to start designing the exhibit. And all of this is partnered with rich nonprofit here, McDonald Steel Heritage. We have still some interest with our partners right here at the Excellence Center. It's still developing there, and that part is what I think may take place with those little models that we've laid here. And they could potentially 3D print those and show the new process as things are going on that front. So, there's a lot of outreach that still has yet to take place, a lot of planning that still has yet to take place, but in reality, the experience, this is all going to be a part of it, and we hope to really take advantage of that entire space over there, from beginning to end, through the different corridors and areas that haven't been. The museum has walls, but the walls have been quite some time, and we're really ongoing to give back really to the people who have given us the people, the products, and really the sweat equity that is paid up moving forward. So we're excited for all of this, and thank you to Carl and Rick and Glenn and the entire company here. We're still working towards that salvage fund that has been established at STEM College and has yet to be repurposed. So these are avenues that we're exploring now to see if we can plant the seeds here and let them grow into little saplings and trees. So I appreciate everyone coming out.
It's very much a works in progress. Before I end, there's a lot of people I'd like to thank. A lot of the photos that I used for this slideshow, I had taken some, Martha took some are from Rick, some Sue had taken. Yeah, there were a lot of help that I had with this. Judy cleaning up some of the equipment. Some of my friends were here. Jim helped with that video that I shot. Harry helped. There's a lot of people that helped bring this all together just for this presentation. So yeah, if I'm forgetting anybody, I apologize, but thank you all. And yeah, that's basically it. Again, any questions, let me know. Feel free to look at anything up here, and thanks for coming. Good seeing you. And I can finish my piece of pizza now.
I would like to see the form tool you used on your part. Only because I know better.
It was a 25,000 slide radius. It goes straight across the hall.
Not super small. Now, when they.
That's a good question. Well, some of these, if you look at it, so you wouldn't have. What I think, because they did two shapes. I think they had. Because when you look at this lake, they could have and then not only did you have the individual, but the whole thing that was lines on, there's two channels. No, McDonald Steel, they need pretty much everything in that
That's impressive.
Some things that can actually be done.
Yes, actually, there were. That's a great question. For this shape.